Hey, seventh grade. Here we are, Monday, and this is lesson 2.8 Literal Equations and Dimensional Analysis. That is a great title. To give you just an idea of what it means, literal equations are equations that have many different variables. Usually it's called a formula because you get a formula that has a lot of different variables in it. And another word for it is literal equation. Dimensional analysis is something we've done before. That's where you change something from, like miles per hour into feet per second. And we have done this before. We did it last year, and hopefully you'll remember it. So I'm going to show you what they want you to do on this assignment. Get to my pen going here. And so for 1 through 4 here, it says solve each equation or formula for the variable indicated. So like this one, it has this equation right here, and it says solve it for A. So what that really means is you need to get everything away from A. I'm looking at the answer. Just trying to see what it is. So for this one, you want to solve it for A. So first thing we need to do is we need to get all the A's on one side in this one. Whoa. What is going on? I did not expect that to happen. Stop. Leave me alone. All right, I'm back. Don't leave me in charge of technology. It'll never go well. Just don't touch the green circles. That's the lesson for the day. Okay, my screen went weird on me. So I'm gonna move the negative 8a. I'm gonna move it over here to the 5a, so I can get all the a's on one side, and we're gonna move the smaller one. That's what we need. We need to move that smaller one. So add 8a to both sides. So that means I'm going to have 13a plus c. And that equals 0 because there is nothing else on that side because I moved the negative 8a from over here to the other side. So then I need to move the c to the other side, minus c. So I have 13a equals c, and then I have to get rid of the 13, so divide by 13, divide by 13. And my final answer should be a equals c over 13. Yep, you know what? I made a mistake, didn't I? This should be negative c over 13. Good thing I have the answers in front of me, or I would get them all wrong. Just kidding. I probably wouldn't get them all wrong, just most of them. Number 2 has 7h plus f equals 2h plus g. Solving it for g. All right, well, that one looks pretty easy. I think I'm going to move the 2h. That one just looks like it's going to be 5h plus f equals g. Well, that's pretty simple. All right, let's see. This one I'm solving number 3 for k. Whew. First rule of life, get everything off the bottom. I should have k plus m equals negative 7n because I multiplied this side by negative 7 and the other side by negative 7. And of course over here that cancels out, and so hopefully that all makes sense. And if I'm solving, wait a minute though, I'm solving for n, right? No, for k. I can't even read the directions. Solving for k. Great. All I have to do is subtract m from both sides, and I should end up with a mess when I cross all this out. I should end up with k equals negative 7n minus m. Okay? And this one here, I'm solving it for p. Now, this one doesn't look too bad because I think this whole thing right here is multiplying times p. So I think I should just have to divide both sides times that whole thing. Multiply the whole thing times R plus S. So I should end up with Q over R plus S equals P. Because all I had to do there was just divide both sides by the same thing. I think that's right. There you go. That's the whole thing for those kind. Let's see. So here, they give you the formula, and the first thing they say is solve the formula for H. Sorry, I can't make that any bigger. That's as big as it gets. It's on the page, though. You can look at it in your book, too. And if I'm looking at this, everything else right here is multiplied by H. So I'm going to leave H there, and on that other side, I'm going to divide both sides by pi r squared. I should have volume over pi r squared equals H, right? Because I just divided both sides by pi r squared. There is a beautiful square right there. And then it says, what's the height if the volume is that and the radius is that? So you just put the number for the volume in here, and then you divide the volume by pi and divide the volume by the radius squared. And they give you the radius there, so it's divided by 1.5 squared. So you can do that in different parts. You could do 56.52, and then you could do pi times 1.5 squared. You could do the 1.5 squared, multiply it times pi, see what that is, and then divide 56.52 by that. That's the kind of stuff that you're doing on that. Now, let's look at number 7. A fisheye lens, minimum focus range of 13.5 centimeters. And then it says 1 centimeter is equal to about 0.39 inches. What's the maximum focus range of the lens in feet? Interesting. So this is one of those dimensional analysis things, because I have 13. I'm not going to have room for this. 13.5. I'm going to do it the way that we did it before. 13.5 centimeters for 0.39 inches. No, I'm going to back up. I'm going to erase that. So, minimum. Yep. So 1 centimeter is equal to that. So we need to do 13.5 centimeters times that number of inches. So, and they want it in feet. Well, okay. So first, let me get my calculator here. I'm doing 13.5, yikes, times 0.39. So I get 5.265. And that is in inches. And then they want to know it in feet. So I think I have to actually take, since this is inches, I have to take that and divide it by 12 inches to get a foot. So let's see what that gets me. I divide that number, 5.265, by 12, and I get 0.43875. 0.438. That is correct. So that's kind of an unusual question that might be interesting to set up. I was wondering if we could set it up like, we know we have 12 inches in 1 foot, and we know we're going to have the 13.5 centimeters. I need to get rid of those centimeters, though. I really need a bigger space to work. Let's go to the assignment. We'll see if there's another one like that we can look at, though, too. All right, let's go here. So, you are going to do these where you're solving for the variable like the ones I did. Same thing here. They ask you to solve for a certain variable. See how that goes, because like this one here, you could multiply, I always forget to turn my pen back on. You could multiply both sides by h squared because you have to get it off the bottom. If you're solving for w, you have to multiply both sides times h squared to get it off the bottom. But then you're going to have that w still over here, but you have to get rid of the 703. So I think I'm going to have h squared times b divided by 703. All right, that's how you got to do it. You got to solve it for that. Let's see, 18. So here are some of the dimensional ones that, they have more here where you're, a couple here where you're solving for a certain variable. Some of these are going to be tricky, so do the best you can on those. 18 has the dimensional analysis thing too. If each lap is 100 meters long, how many laps equal 1 mile? So we know that, and then they give you a hint. 1 foot equals that many meters. So we have 5,200, 80. That's beautiful. Let's try that again. 5,280 feet. So you have 5,280 feet in 1 mile. Okay? And then they have 100 meters. So we want to know how many 100 meters fit into 5,280 feet. So, and the hint they give you is 1 foot is about this 0.3048 meters. So if I take 100 meters, all right, I take 100 meters and, divide it by 0.3048 meters. Because, if they're saying this many meters are 1 foot, well, if we find out how many of that size meter is in 100 meters, then you will know how many feet there are in 100 meters. So let's try that out right now, and let's see what I get with my slow to turn on calculator. And I'll probably show you a little hint on like 20 and 22 also. Okay, so here I go. So 100 meters. And I'm dividing that by 0.3048. And what I get is I get pretty much 328. I get 328. So that means in 100 meters, there are 328 feet. Okay? And now they want to know how many laps you would do for a mile. Well, we know that each lap is 328 feet. So I'm going to do my 5,280 divided by the 328. And you get just about 16 laps. So I'm going to come back to that one because that one I want to make sure we know how to set that one up. Let me clear that off for now. And I need a little more room to work. All right. We're going to keep going for a minute before I come back to the swimming one. That was just kind of a hard one to set up. I wanted to look at 21. Let's see, is that the one I really... 22, solving it for C. Solving that one for A. 22 is a really interesting one. I'll even show you partway how to get 22 to work. And it says you're solving it for A. And the hard part is you have A on both sides. So first thing I'm going to do is I'm going to do it this way, because this is an interesting one. If I was doing this one, I would move this Y to the other side. So then I would have this Z plus Y on one side, and then I would move the AX to the other side, and I would end up with AW minus AX. All right. So hopefully that makes sense, because I have the AW is already here. I added Y to both sides to get Z plus Y. Then I subtracted the AX to get the AX over here. Okay. Now, this is one where I kind of wonder where they get their ideas from, because what you really want to do here is you want to notice that both of these parts have an A. And so you can actually factor that out. A times W minus X. Okay, so this part's gone. Now, to get rid of everything here, that's being multiplied right now. So you would divide both sides by that. And that would look like this. You would get Z plus Y over W minus X. Because remember, I'm dividing both sides by this W minus X thing. You know, I didn't put the parentheses in there, but you would end up with Z plus Y over W minus X equals A. So that one is the hardest one. The other ones aren't bad, because like this one, you're solving for N. And, you know, you have to get all your N's on one side, but then you're just going to divide by a number. That shouldn't be too bad. All right. And I want to show you one more thing here before we're done, because I think for this, you're starting with number 8 and going to something, which I'd love to show you what it is, but I don't have that. My other list on my other Chromebook died. I'll look that up in a second here too. So for 24 and 26, you're supposed to convert what they have into something up above that works well. You know, so you have like feet per second. What do you want to turn it into? Persons walking 3.4 miles per hour. What do you want to convert it into? And you really have to decide. The only one that's kind of, I don't know. I mean, you could do them all. You have meters per minute, but you just have to decide which one you want to do. I'm going to set one up just to show you how to do this. So like if I did the snail moving at 3.6 meters per hour, and if I wanted to convert that from meters per hour into millimeters per second. So I have 3.6 meters per hour, and I'm converting that into millimeters per second. This is one of those ones where I have to ask you how many things are changing, and hopefully you will say 2. And so that's where, when we did this before, you make 2 lines in here. Sorry, I don't have enough room to do this, but these are all multiplication lines, and you got to start getting rid of stuff. So I know I need hours to disappear, so I'm putting hours up here. So that cancels top and bottom. And then seconds will go down here because the seconds are going to end up over here and they should be there. So then I know I'm getting rid of meters. So meters has to go on the bottom because I need the meters and the meters to cancel out. And the one over here that goes with meters is millimeters. I hope you remember that. Now we have to put in our numbers. I think there are 3,600 seconds in 1 hour. And I believe there are 1,000 millimeters in 1 meter. That's what the dimensional analysis does. So now you multiply 3.6 times 1,000. That should be 3,600. And you're dividing that by, this is funny, 3,600, because that's the number that's on the bottom right there. So you multiply everything on top, divide by the number on the bottom. And there you get 1 millimeter in 1 second. That's how those work. So try that with 24 and 26 and see how that goes. And still trying to find out how far we're going. I can't believe I would just stop at 28. And I know you're hoping I would stop at 28, but that would be highly unlikely. All right, let's go to the next page. Just quickly take a look. It looks like we're going to stop at number 34. 30 and 32, these are a lot like what we've done before. You just have to write it as math, and then it's just like that. You're solving for that variable. No problem there. 34, a car driven X miles a year averages M miles per gallon. Write a formula for G, the number of gallons used in a year. All right, so gallons. Whoop, yeah, see, once again, I turn the page. I forget my pen. Okay, so just to help you out, gallons used in a year would be the number of miles you drive and divided by the miles per gallon. So, like, for example, if you drove 100 miles in a year, 100 miles in an entire year, imagine that, 100 miles in a year. That's a lot. And if your car got 4 miles to the gallon, now that's not a lot. That's not a lot of miles per gallon. But if you think about it, X is miles. If I'm driving 100 miles in a year, and if my car gets 4 miles to the gallon, 100 divided by 4, I would need 25 gallons of gas. That's what the G would be. If you make it easier, you'd say, what if my car got 100 miles to the gallon? Well, 100 divided by 100 would be 1. You'd need 1 gallon. If it wasn't quite that easy, if it was 10 miles to the gallon, you would need 10. So hopefully that makes sense how that works. That's a good way to do the formula. Then it says if the average price of gas is P dollars per gallon, write a formula for the total cost in dollars of driving this car each year. So hold on while I get my handy dandy formula out. Okay, so what they're talking about in B is you have this total cost, and your total cost would be the price of gas times the number of gallons that you get from the previous part, because it makes sense if I'm using so many gallons. Trying to make that a multiplication. It's not cooperating. Here we go. Sort of. Your total number of gallons times the price. And then part C talks about if car A is 15 miles per gallon, that would be your number here, 15 miles per gallon. Car B is 35, so you're going to have to do that equation again with 35 miles per gallon. And if you average 15,000 miles, that's your distance, 15,000 miles each year. How much money would you save on gas per week using car B instead of car A if it's $3? So you know, take each mileage, figure out how many gallons you're going to need, and then you multiply it times the price, 3. And you get your total cost. So it shouldn't be too bad. So I think that's 8 to 34 even, and see how it goes.